Hi, today our topic is QUIC versus TCP. Does QUIC beat TCP for the transfer of large files? It's going to be presented by myself, Arham, Mark, Rishav, Vincent, and Zach. Internet usage has evolved significantly with applications like video streaming, cloud storage, mobile networking, and industry adoption, driving the need for more efficient data transmission. TCP, being the backbone of reliable data delivery for decades, struggles to meet this criteria and demands of low latency and enhanced security required by modern applications. This led to the development of QUIC, which addresses these limitations with lower latency and stronger security, making it ideal for today's needs. While QUIC's general benefits are well studied, its use in large file transfers such as with rsync remains unexplored. Our research fills this gap, making it both timely and highly relevant. Over to the next slide.
Right. Our experimental setup for this is a custom implementation of a TLS/TCP client and server, as well as a corresponding QUIC implementations. We used Mininet to simulate the network, and the Microsoft QUIC implementation, which is an open source implementation of QUIC. We test the connection time and total transfer time with varying file sizes from 1 megabyte to 4 gigabytes, and a varying number of file counts. For our network conditions, we have 1 gigabyte or 1 gigabit per second bandwidth and no delay between the packets, and we use 2 hosts and a single link, meaning no intermediate switches. Next.
Right, so here are the results. We tested with a variety of files from 1 megabyte, 10 megabytes, 100 megabytes, all the way to 4 gigabytes. But for simplicity, we're just going to be showing 1 megabyte and 1 gigabyte files. Specifically, we tested 100 to 4,000 1 megabyte files and 1 to 4 1 gigabyte files. So about 4 gigabytes worth of data for each test. For connection time, as we can see with these plots, the QUIC seems to be consistently slower or consistently faster than TCP, and these results were pretty much consistent through like all types of files. So 1 megabyte, 10 megabytes, 100 megabytes, they all seem to have similar differences. However, for total file transfers, we can see that QUIC is slightly slower than TLS, and the number of files counts increases, the time for QUIC increases as well. And we notice the same general trend across all types of files as well. And we found this really interesting, and we're going to explain why this might be the case.
Yeah, so as you can tell from our graphs, QUIC tends to consistently have a lower connection time than TCP with TLS, which makes sense given the design goals of the QUIC protocol. But our transfer time was much slower with QUIC, around 60%. And the reasons for this could essentially boil down to the implementation of our client and server. There's some differences in how QUIC is used, namely, they use event-based transfers, and so it uses more of an event and callback pattern for programming, whereas a traditional TCP and TLS server will, open a socket and write to it, much like you'd expect. And so that's one of the potential reasons there could be suboptimal usage of the QUIC library. And we also did not make use of independent streams, which is a big feature of QUIC. We treated it essentially as one stream, kind of like the abstraction provided by TCP.
So the main takeaway of our project is that QUIC is best suited for settings that have frequent connections or disconnections. Naturally, the main use case would be for Google searches, where you would have one connection per search. So some directions for future work would be to conduct tests with frequent connections. For example, given our current framework, we could adapt it to have one connection per file transferred. Additionally, we could modify the code to fully utilize MS-QUIC features, such as independent streams, as was said, and also fully using event callback. And lastly, the experiments already run within Mininet, so it's easy to modify some of the network conditions to emulate things like packet loss or add multiple hosts to the network. Hopefully with these different modifications, the results would be more interesting.
Right, so we have two, this is a demo for our project. On the left, we have our terminal for the server. On the right, we have a terminal for the client. We can show that these are indeed different machines by showing the IP address. We can see that the IP address for this one is indeed different from the IP address of the client. On the server, we have no files, if I type ls. But on the client side, we do have some files, and these files we want to transfer to the server. So on the server machine, we can run the server using TLS, for example. On the client side, we can run the client to transfer the file. We want to use TLS, and we want to send them to the server. Let me copy the IP address of the server, and we want to transfer all of the files. All right, we sent it, and over here, if I kill the server and type ls, I can see that the files did indeed transfer. And I can do the same thing for QUIC as well. So I can run the server with the QUIC protocol. And over here, I can run the same client command except with QUIC. And you can see some differences in the statistics between TLS and QUIC, which we'll mention in our report in the presentation. Just to confirm that they did transfer, I can go back on the server, kill the server, and type ls, and we can see the files did indeed transfer. This was just a quick demo of our project.